Assalamualaikum and hello everyone. My name is Sabrina Halis binti Helmi Skandar. My metric number is D202411111357 and I am from 8014 ISMP Mathematics. Today, I would like to present Za'Ba House, one of the historical heritage buildings at University Pendidikan Sultan Idris, UPSI. First, let me talk about the history and background of Za'Ba House. Za'Ba House is named after Pendeta Za'Ba, a well-known Malay scholar who made major contributions to the Malay language and education. He lived in this house while working as a translator and author at the Sultan Idris Training College SITC from 1924 to 1939. Today, the house has been transformed into a living museum under the management of UPSI's National Museum. It preserves Za'Ba's legacy by displaying his books, manuscripts, personal collections, photographs, and writings. These exhibits help visitors understand his important role in Malay literature, education, and language development. Pendeta Za'Ba is well known for modernizing Malay grammar and helping to standardize the Malay language. His work contributed greatly to the education system and nation building during the pre-independence period. Because of its historical importance, Za'Ba House is now included in the UPSI Historical Heritage Road. The house is located at the Sultan Abdul Jalil Shah campus located at University Pendidikan Sultan Idris in Tanjung Malim, Perak, Malaysia. Next, let's look at the usage and function of Za'Ba House. Today, Za'Ba House serves as a living museum and an important historical heritage site. It is an educational destination for students, researchers, scholars, and tourists who are interested in learning more about Malaysian history, the Malay language, and Pendeta Za'Ba's contributions. Inside the museum, visitors can explore a collection of Za'Ba's personal belongings, original manuscripts, books that he wrote or translated, as well as historical photographs and documents. These collections provide valuable knowledge about his achievements in literature, language standardization, and educational reform. Finally, let me share the size of the building. Za'Ba House has a floor area of approximately 224 square meters. Although it is not a very large building, it has a great historical and educational value. It continues to preserve the memory and legacy of one of Malaysia's most respected scholars for future generations. In conclusion, Za'Ba House is more than just a historic building. It is a symbol of knowledge, education, and the preservation of Malaysia's cultural heritage. Visiting this house allows us to appreciate Pendeta Za'Ba's lifelong contributions and understand the importance of preserving our national history. Thank you.
Assalamualaikum and hi everyone. My name is Nur Ashikin binti Samad and my metric number is D2024111358 and I am from 8014 ISMP Mathematics. Okay, for this section, which is 2.0, I will explain the geometry found in a Za'Ba house. Based on our observation, the architectural design of the Za'Ba house incorporates many geometry elements. Okay, we can see this element in different parts of the house, such as the roof, doors, windows, wall vents, doorknobs, and the concrete pedestals. These geometric features are not only used for decoration, but they also serve practical purpose. For example, they help improve the strength, stability, and the functionality of the building. This shows how geometry can be applied in the real-life situation, especially in the traditional Malay architecture. Overall, the design of the Za'Ba house demonstrates that the mathematical concept play an important role in creating a structure that is both functional and visual appeal. Okay, now I will continue with section 2.1, which focus on the geometrical shapes identified in the Za'Ba house. Okay, based on our observation, we found both two-dimensional, which is 2D, and three-dimensional, which is 3D shapes in different parts of the house. These shapes are important because they contribute to design, strength, and the functionality of the building. Okay, for two-dimensional shapes, the first shape is rectangle. This shape can be clearly seen in the doors and windows of the house. Rectangles are commonly used in architecture because they provide a simple, balanced, and practical design. Their straight edge also make a construction easier while maximizing space and the natural lighting. Next, the second shape that I found is the triangle, which can be observed on the roof and the timber support structures. Triangles are known for their strength and stability. In the Za'Ba house, the triangular roof design not only strengthens the structure but also allows rainwater to flow down efficiently, which is important in the Malaysia tropical climate. Okay, next, we identify a circle on the doorknob. Although it is small architectural feature, it is good example of geometry in the everyday objects. The circular shape allows a smooth rotation, making it easier open and close the door. It's also a simple decorative element to the house. Okay, another shape found is the trapezoid, which can be seen in the wall vent. This shape contributes to the traditional appearance of the house, while also serving a practical purpose. The wall vent helps improve airflow and the ventilation, making the indoor environment more comfortable. Okay, now we're moving on the three-dimensional shapes. Okay, we identify a cuboid in the concrete pedestal located at the front veranda of the house. A cuboid is a solid shape with rectangular faces, and it is commonly used in construction because it provides strong structural support. In this case, it helps support the pillars and distribute the building loads. Lastly, we found a cube-shaped pedestal at another section of the house. Since all its sides are equal, the cube provides good balance and stability. It also helps to distribute the weight and the structure evenly to the ground. In conclusion, the geometrical shape found in the Za'Ba house demonstrate how geometry is applied in traditional architecture. These shapes are not only aesthetically pleasing but also play important roles in ensuring the strength, stability, and the functionality of the building.
Assalamualaikum and a very good day to everyone. My name is Siti Nurul Aina binti Mas'ud with number matrix D2024111134 from 8014 ISMP Mathematics. And today, I will present the geometrical concepts found in Rumah Za'Ba. For the two-dimensional shapes, I identified rectangles on the main door and windows. A rectangle has 4 sides and 4 right angles, each measuring 90 degrees. For this shape, the perimeter is calculated using the sum of all sides, while the area is calculated by multiplying the length by the width. Alright, next, I identified triangles on the roof and timber columns. The roof forms an isosceles triangle which has 2 equal sides, while the timber column forms a right triangle containing one 90-degree angle. The perimeter of a triangle is obtained by adding all these sides, and its area is calculated using 1/2 multiplied by the base and height. I also found a circle on the doorknob. A circle has no sides or corners, and the total angle around its center is 360 degrees. The perimeter of a circle is known as the circumference, while the area is calculated using the radius of the circle. Another shape identified is the trapezoid on the wall vent. Based on the measurements, it is a right trapezoid because it contains right angles. The perimeter is found by adding all the sides, while the area is calculated using 1/2 multiplied by the sum of the parallel sides and the height. Next, for the three-dimensional shapes, I identified a cuboid on the concrete pedestal. A cuboid has 6 rectangular faces and right angles. Besides calculating its surface area, the volume can be determined by multiplying its length, width, and height. Next, I also identified a cube on another section of the pedestal. A cube has 6 equal square faces and all angles measure 90 degrees. Its volume is calculated by multiplying the side length by itself 3 times. In conclusion, the geometrical concepts found in Rumah Za'Ba demonstrate the application of geometry through different shapes, their angles, and the methods used to calculate perimeter, area, surface area, and volume.
Assalamualaikum warahmatullahi wabarakatuh, and good day to my teacher and friends. My name is Muhammad Izahana bin Hafizan. My metric number D2024111083. My program is 8016 ISMP Science. Today, I am excited to present my project on geometric transformation found in a traditional Malay house, specifically the historical Za'Ba house at Upsi. In this presentation, I will discuss the geometric transformation identified in the house, focusing on translation and reflection, followed by a brief summary of our finding. Through this study, we can better understand how mathematical concepts are applied in traditional Malay architecture. Let's start with translation, which basically means shifting a shape uniformly to create a repeating layout. We can see this in several main features. First, on the back door, the rectangular inner panels shift uniformly from top to bottom. Second, the massive front pillar refit horizontally across the porch to support the weight of the room evenly. Looking at the exterior pattern, the wooden wall boards are translated vertically, stacking neatly one after another. Finally, the wooden rail on the balcony shift horizontally to the right, keeping an exact equal gap between each piece. Next is reflection, which is used everywhere in this house to create perfect structural balance and symmetry. The side windows are mirrored perfectly across the central dark pillar on the wall, making the left window the object and the right window its image. Under the porch roof, the V-shaped timber columns form two identical right-angled triangles reflected along the center line. Up on the roof itself, the triangular vent is split by a vertical line right in the middle, mirroring the left design onto the right side. Lastly, looking at the carving on the main door and front windows, the middle line acts as a mirror, making both sides match each other flawlessly. In conclusion, analyzing the Za'Ba house shows us that traditional builders were highly skilled. They used translation for structural order and reflection for visual beauty. This project proved that geometry is not just a classroom topic, but a beautiful part of our culture and heritage. In summary, this study has helped us understand how geometry is applied in real-life situations through our observation of the Za'Ba house. We successfully identified various 2D and 3D geometric shapes, carry out measurement, and analyze transformation, such as translation and reflection found in the patterns and structure of the house. Overall, the study showed that geometry is not only learned in the classroom, but also exists all around us and plays an important role in our daily life. Thank you.
Assalamualaikum and good morning everyone. My name is Seni with metric number D202311077751. I am from SMG3013. In conclusion, this class has helping us understand that geometry is not only something we learn in classroom, but it also can be seen in real-life structures such as Za'Ba house. Through our observation of the shape, motif, pattern, and symmetry found in the building, we learn that mathematical is closely connected to traditional architecture. This project also allows us to appreciate the beauty and the practicality of the house design, serve as decorative and functional purpose. Most importantly, we realize that geometry is present in our daily life and can be found in many things around us. Therefore, studying geometry helps us better understand and appreciate the world we live in. That's all from us. Thank you for paying attention.